Let's look at section 11.3, graphing parabolas by translations. The graph of the function f of x equals a times the quantity x minus h squared plus k has the following properties. The graph is a U-shaped parabola. The parabola opens upward if the leading coefficient a is positive, and it opens downward if the leading coefficient a is negative. The vertex or the turning point of the parabola is at the point h, k. The axis of symmetry is located at the vertical line x equals h. The y-coordinate of the y-intercept of the parabola is equal to f of 0. If the parabola has any x-intercepts, they can be found by setting f of x equal to 0 and then solving for x. The domain of a quadratic function is the set of all real numbers from negative infinity to positive infinity. The range can be determined from the graph. Let's get started. We'll look at the parent graph of all parabolas, and that's the simplest one, f of x equals x squared. For this, I like to make a table for the values. Let's pick x, and we'll pick f of x. So I'll like to pick points like -2, -1, 0, 1, 2. These are just random points, but they give us a general idea of what the parent of all parabolas look like. So -2 squared is +4. We're squaring them because it's f of x equals x squared. We're substituting the x here with a -2. -2 squared is +4. -1 squared is a +1. We have a 0 here. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So this is going to give us the general shape of the parent graph. -2, 4 is a point here. -1, 1. 0, 0. 1, 1. And we have 2, 4. This is the general shape of our parent graph. Again, the vertex is located here at the origin. That's the turning point of our parabola. And so this is useful when graphing parabolas because all we have to do is shift it left, right, up, or down, but the general shape is the same. Let's try another question. Let's graph f of x equals x squared plus 2. What's going to happen here is the vertex is going to be shifted up 2. This 2 causes my graph to shift up 2. So if you write down the vertex, the formula for the parabola is f of x equals a times x minus h squared plus k. The h and the k tell us the location of the vertex. So for this problem, I can rewrite it as f of x equals x minus 0 squared plus 2. That means my vertex is h, which is the 0, and k, which is 2. So the vertex is 0, 2. That forces my graph to be shifted up 2, but the shape is still the same. If you go back to the parent graph, we're going to go left 1, up 1 for the second point, right 1, up 1 for the third point, left 2, up 4, and then right 2, up 4. So this is always starting from the vertex. Let's go to our original problem. We're going to go left 1, up 1. That's our second point. Start again at the vertex, right 1, up 1. That's our third point. For the fourth point, we go left 2, and then up 4 spaces. So you can see this looks exactly like the parent graph, but it's shifted up 2 spaces. So we'll sketch our parabola here. Let's redo this to look a little bit better. Here you go. This is a little bit better. So this is the graph of a parabola. Again, the shape is exactly the same as the parent graph, it's just shifted up 2. Let's look at this graph. We can rewrite it as f of x equals x minus 0 squared minus 3. So what's my vertex? My vertex is again h comma k. This is the h, this is the k. So the vertex is 0 comma negative 3. So this shifts our graph down 3 spaces. So this is the vertex 0 comma negative 3. And the shape is the same. So from the vertex we go left 1, up 1. We go right 1, up 1. And then we restart again at the vertex. Left 2, up 4. And right 2, up 4. We could also use symmetry if we wanted to. Make sure we're doing this right. And it does look like a nice looking parabola that's shifted down 3 spaces. So it seems like the k on the right side here forces our graph up 2 spaces if k is positive 2, and down 3 spaces if k is negative 3. So the k controls the vertical translation. Let's look at the next graph. Here we don't really have a k, but it is there. It's an invisible 0. So this means our vertex is the point 1 comma 0. It is a positive 1. If you look at the original formula, it's x minus h. So h is after the negative symbol. H is after the negative symbol, and that means that our h is actually a positive 1. That causes my vertex to shift to the right 1 space. It doesn't shift to the left, it actually shifts to the right 1 space. And again, I'm going to draw that general parent graph right here. Left 1, up 1, right 1, up 1, left 2, up 4, right 2, up 4, always restarting at the vertex. And so if inside the parentheses we have an x minus 1, it actually shifts the graph 1 space to the right. It doesn't go left. So that's something to consider. If it's x minus 1, it actually shifts to the right 1 unit and not left. For the fourth graph, the vertex is actually negative 3 comma 0. Why is it a negative 3 and not a positive 3? If I rewrite this equation, you get x minus a double negative 3, and so that's why it's a negative 3 and not a positive 3. The negative here is not the h, it's whatever is after the negative, and that's negative 3. So it's always opposite. If you look up at the parentheses, it's always the opposite of what you think. So let's graph the vertex negative 3 comma 0, and it looks exactly the same. It's just shifted 3 spaces to the left. So we're going to shift 3 spaces to the left, and this is our parabola. The shape is still the same. We go left 1, up 1, right 1, up 1, left 2, up 4, 1, 2, 3, 4, right 2, up 4, and so we have our parabola. In this question, we want to state the domain and the range as well. I always start by stating the vertex. The vertex, again, is the h and the k. The h is a positive 3. It's whatever is after the negative symbol here, so it's a positive 3, and k is a 4. That moves our graph to the right 3 spaces and up 4 spaces. And all we got to do is go left 1, up 1 from the vertex, right 1, up 1, left 2, up 4, and right 2, up 4. Again, we always restart at the vertex. Now I can state my domain. Well, the domain for all parabolas is from negative infinity to infinity, because it goes to the left forever, to the right forever. But the range, we can look at the graph. If you were to ride on the elevator, you would have to be on the 4th floor to see the bottom of the graph, so that's a square bracket 4, and it goes up forever, so it goes to infinity, and that's the range. In the next example, we'll look for the vertex again. Be careful, what is the vertex? We'll rewrite it so it's easy to tell. We're going to write it as x minus a negative 2 squared plus 5. H is negative 2. It is not a positive 2. K is 5. That means my graph is shifted to the left 2 and up 5 units. This is the vertex, negative 2, 5. And again, we'll draw the parent graph here. To the left 1, up 1. To the right 1, up 1. To the left 2 spaces, and then up 4 spaces. 1, 2, 3, 4. To the right 2 spaces from the vertex, and then up 4 spaces. Making sure it's symmetric. And that's our graph. The domain for our parabola is always the same, negative infinity to infinity, because it goes forever to the left, it goes forever to the right. The range, however, only goes down to a positive 4, but it goes up forever. So it's square bracket, positive 4, all the way to infinity. Look at the picture and you'll be able to figure out that range. Again, we'll start by rewriting our equation with a double negative, just to read the vertex a little bit easier. This is my H, this is my K. So the vertex is negative 1, 3. So I'll start by graphing that. Negative 1, 3. But remember, this has a negative leading coefficient. This is negative, which means our graph is going to be upside down. So when I go left 1, I don't go up 1, I go down 1. When I go right 1 from the vertex, I go down 1. If I go left 2 spaces, I do not go up 4, I go down 4 spaces, because this is going to form an upside down parabola. Go to the right 2, we're supposed to go down 4 instead of up. And so this changes our graph to facing down. And this is our upside down parabola. The domain, well, it's still going to go forever to the left, forever to the right. But the range, however, is different. We can go down forever and we will still see the entire graph. So it's negative infinity downwards, but upwards we have to stop right here at 3. So the range goes up to 3 with a square bracket because it's a closed circle, it's included. State the rotation, horizontal shift, vertical shift used to graph the given function. In part A, we have x plus 13 squared minus 7. The h is negative 13. Again, you could think of this as a double negative. The k is negative 7. There's no number in the front, so there's no rotation, there's no flip. So we have a horizontal shift to the left, because it's negative, of 13 units. And the k is negative 7, so we have a vertical shift of 7 units. It's going to actually go down 7 units. So we know what this graph looks like without graphing it because we could read the h, k, and that leading coefficient. Part B, f of x equals negative x minus 4 squared plus 30. This negative in the front, what does that do? It causes our graph to rotate or flip upside down. So there is a rotation. Rotation. The h is positive 4, so that means we're going to shift 4 units right. And this k is 30, that means it's going to shift up our graph 30 units. Again, we have a general idea of what this parabola looks like without even having to graph it. Let's look at the maximum and minimum values of a function. The smallest possible output of a function is called the minimum value of the function. The greatest possible output, again they mention that word output, of a function is called the maximum value of a function. Let's find the minimum value of the function f of x equals 3x squared minus 12x plus 17. If we have a graph with a leading coefficient that's positive, I know it's going to have the shape of a parabola facing up, and therefore it must have a minimum. This is a minimum located at the vertex. Now, how do we find that vertex? Well, we can use a formula that we had earlier. X equals negative b divided by 2a is going to give us the x-coordinate of the vertex. And so that's what I'm going to use. We have a negative, and b is negative 12. A is a positive 3. So figuring this out, we get a positive 12 on top divided by 6, which gives me 2. This is the x-coordinate of the vertex. To find the y-coordinate, we're going to plug it into the equation here. So f of 2 equals 3 times 2 squared minus 12 times 2 plus 17. And so we could simplify this as 3 times 4 minus 12 times 2 plus 17. This simplifies again as 12 minus 24 plus 17. And that gives me 5. What does this mean? Well, it means the vertex is at the point 2, 5. But the question's asking what is the minimum value of the function. The minimum value of the function is 5. The minimum is equal to 5. That is the solution to the problem. Because the output is actually the y-coordinate. So the y-coordinate of the vertex is the minimum value of the function. The answer is not 2, 5. The answer is 5 because that's the minimum output of our function. Find the minimum or maximum value of the function. There is a negative in front. What kind of parabola are we talking about? We're talking about an upside down parabola. And therefore, the vertex is located here. So it doesn't have a minimum, it actually has a maximum. And to find the maximum, all we have to do is find the vertex. Again, we'll use the formula x equals negative b over 2a. B in this case is 10, so we have a negative 10 on top. Divided by 2 times a. A is the negative 1. This gives me a positive 5. what do we do with this 5? Well, we're going to plug it into the function f of x. F of 5 equals negative 5 squared plus 10 times 5 minus 35. This is negative 5 squared, which is actually negative 25 because the parentheses only includes the 5, plus 50 minus 35. So we'll do all of the calculations here, and we get negative 10. So that means my vertex is located at the point 5, negative 10. So that's our minimum. Our minimum is negative 10. What does that mean? It's negative. So that means the vertex is actually below the x-axis. If you were to draw this graph, you would have the graph completely below the x-axis, and that's why my mistake here, it's not the minimum, it's the maximum. So let's correct that. Let's make sure we write maximum. This is the maximum because it's the highest value of the output. So the maximum is negative 10. So please correct that. It's maximum and not minimum. So the maximum is negative 10, and that's the highest value of the function, but it's completely below the x-axis. So that's what we can visualize from the problem. Let's try it again for the third example. Now we could use x equals negative b over 2a again and then plug it in to find the y coordinate, but that's a very tedious task because we would have to square this out, then distribute the 5. That's just tedious. But I could read off the vertex a lot quicker. The vertex is 2, 47. That means the function has either a minimum or a maximum at the output. This is a positive 5. That means the graph faces up, and therefore we have a minimum, not a maximum. So the minimum of my function is 47. That's our solution. The minimum is 47. What is the maximum product of two numbers whose sum is 40? The first step is to label the first number as x, because we don't know what that is. The second number, we'll give it a name, let's call it y. So we have two numbers, but we want to make sure their sum is also 40. That means x plus y should be equal to 40. And that means I can solve for one of the letters. Let's solve for y. So we'll subtract x to both sides. Y is equal to 40 minus x. This is good because we could use the second number instead of y. We could replace it with 40 minus x. That gives us less variables to work with. What is the maximum product? So we need a function. We'll create a function that represents the product of the two numbers. So let's say f of x, which is our product function, is equal to the first number times the second number. But instead of the second number being y, let's put it as 40 minus x. We'll distribute, and this gives me 40x minus x squared. It is a parabola facing down. How do I know that? It's a negative x squared. I could rewrite it so it looks better. It could be written as negative x squared plus 40x. So it is a parabola that faces down. So it has a maximum. It does not have a minimum. It has a maximum. To find that maximum, we need to find the vertex, and again we use this formula, negative b over 2a. The b is 40, and the a is our negative 1. We have a negative 40 over 2 times negative 1, which gives us an x value of positive 20. This is the x coordinate. So we'll need to plug it into the product function. F of 20 equals 40 times 20 minus 20 squared. So we'll multiply this out. 40 times 20, that's going to give us 800. And 20 squared, that's 400. F of 20 is equal to 800 minus 400, which is 400. That means my vertex is located at the point 20, 400. So what is the maximum product? We know the maximum occurs when x is equal to 20, and the maximum of our function f of x is at 400. So the max is the output, which is 400. A farmer wants to fence off a rectangular pen for some pigs. If he has 120 feet of fencing, what dimensions would give the pen the largest possible area? So we have a rectangular fence. We don't know what the length is. We'll call that x. We don't know what the width is. We'll call that y. But we do know that we have only 120 feet of fencing. Since this is a rectangle, the opposite side of x must have a length of x, and the opposite side of y must have a length of y. The area is going to be maximized, so we'll just have to create a function for the area. Recall the area of a rectangle is length times the width. In our case, it's the length is x and the width is y. So we'll just say the area is x times y. But we have too many variables, so how do we replace y with values in terms of x? Well, think about these 120. This 120 represents the perimeter. Now, how do you calculate the perimeter? The perimeter is equal to all of the sides added up together. So that's x plus x, or 2x, and y plus y, which is 2y. So that's the perimeter. The perimeter should total 120. So we have 120 should be equal to 2x plus 2y. This is good because we could solve for y and then replace it in our area equation. Let's subtract the 2x to both sides. We have 120 minus 2x equals 2y. Now we could divide both sides by 2. And look at that. Each of the left two numbers has a factor of 2, so we could divide each of these by 2. And so that gives us 60 minus x is equal to y. This is what y is equal to. That means I could replace my area function, let's call that f of x, with x times y, but instead of y, let's get rid of this y and let's replace it with 60 minus x. So our function that represents the area is f of x equals x times 60 minus x. We can distribute now. And so this gives us 60x minus x squared. Again, this looks like a parabola that faces down because it's a negative x squared. So I can rewrite it for you as negative x squared plus 60x. We're looking for the dimensions that would give us the largest possible area. That means we'll find the vertex first. X equals negative b divided by 2a. B is 60, so we have negative 60 on top, divided by 2 times negative 1, which gives me a positive 30. This 30 is our length. So we have the length is equal to 30. 30 what though? We'll look at our units and it's supposed to be feet. So the length is 30 feet. We know the length is 30 feet and we could solve for the width. To find the width, we just need to plug that back into our equation for y, and we know y is equal to 60 minus x, which means I can substitute this 30 feet, which is x, into the x. So let's make sure we plug it into the right place. We're going to plug this length of 30 into this equation, but for the x. So that gives me 60 minus 30 equals y. And 60 minus 30, that gives you 30. So y equals 30, which implies the width is also 30 feet. So we have the length being 30 feet and the width being 30 feet. That is the dimensions of this rectangle. It's actually a square. The length and the width are the same. Now some of you might have thought, why did we not plug it back into the original function to find the area? Well, the question wanted to find the dimensions, the length and the width. If we wanted to, we could have plugged 30 into f of x. And so we could have plugged 30 into f of x and get this expression. But we were not looking for the maximum area. If you were to do the calculation, you would get negative 900 plus 1,800, which gives us 900. So the maximum area is equal to 900 square feet. But that's not what we wanted. We wanted the maximum, or the dimensions that would yield the maximum area, not the maximum area. So the answer we're looking for is just the 30 feet and the 30 feet. In this example, we are going to look for the difference quotient. The difference quotient is an important formula. It is used in future math classes, so it's important to know the difference quotient. It generally represents the slope on a curve between 2 points. So we could find the slope of 2 points on a parabola using this equation, the difference quotient. Now, how do we do it? Well, we'll start by writing the difference quotient out. We always show our work in every single step to get full points. And then we'll plug in values x plus h into our x of the original function. We plug in an x plus h here and x plus h here. So this gives me an x plus h squared plus, we'll do it again, 3 times x plus h, and then we'll drop down the plus 317. That's just the first part. That's the f of x plus h part. Now we have to subtract f of x. What's f of x? Well, f of x is this. That's the whole thing. That means I need to take the whole thing and subtract it. So we'll write x squared plus 3x plus 317. Be careful. A lot of people forget that you're subtracting the whole thing, so you need a big set of parentheses so we can distribute this negative. On the bottom, we just have h. What do we have to do with the x plus h? Well, I'll do the scratch work here on the side. It means we have to multiply x plus h times x plus h to itself. And if you were to FOIL this out, you get x squared, xh, another xh, and then h times h, that's going to give me h squared, which simplifies to x squared plus 2xh plus h squared. So there's a lot of work to get this. But we can use that over and over. We know x plus h squared is x squared plus 2xh plus h squared. So let's replace that x plus h squared with the value it's equal to. This 3 needs to be distributed, so we'll distribute that. That's 3x plus 3h. And we'll drop down the 317. This negative just makes all of these on the right negative versions of themselves. So we'll have negative x squared, negative 3x, and negative 317. All of this is divided by our h. Now this looks complicated, but a lot of things cancel out. We have the x squareds cancel out. The 3x and the negative 3x cancels out. The 317 and the negative 317 cancels out. What is left over? We have left over a 2x. An h squared is left over. A 3h is left over on the top. And that's it for the top. On the bottom we have an h. Now there is a small typo here. I forgot the h here, so let's add that. Here is our h, and we'll put that back here. So now it's correct. It's 2xh plus h squared plus 3h. So be careful, always double check your work. I caught my mistake because I noticed there was an h missing. Now we're not quite done because each of these has a factor of h. That means I could divide all of the terms by h, and that's going to simplify our expression. Let's write it out. This simplifies to 2x plus h squared reduces with just one h down here. That gives us an h on the top. And this 3h is just a 3 now. So that's it. That's our solution. Our difference quotient is 2x plus h plus 3. Now I want you to practice this on your own, the next problem. It will be on our next exam, so let's make sure you try this on your own. Again, when I do the difference quotient, I need to write down the formula. And then we'll do the substitution. The first step is to substitute the x plus h every single place we see an x. So this is x plus h squared minus 8 times x plus h plus 14. That's the very first part of the function f of x plus h. Now the next part is the minus f of x, which means we're going to subtract the whole thing. Don't forget you need parentheses. That's the most common mistake that I see. People forget the parentheses. So we'll do x squared minus 8x plus 14 inside parentheses. Don't forget that parentheses. And as I said earlier, this part, we did the scratch work in the previous problem. This is just x squared plus 2xh plus h squared. That scratch work is already up here. We've done that earlier. But if you don't know how to do that, make sure you FOIL that out on your own. We'll distribute with the negative 8. This is negative 8x, negative 8h. And then a plus 14. We'll distribute this negative out. Negative x squared, positive 8x, and a negative 14 when we distribute the negative. Now it looks like a lot of work, but a lot of things should cancel out. We have x squareds canceling out with the x squareds. The negative 8x cancels out with positive 8x. 14 cancels out with negative 14. And we'll see what's left. We have 2xh left. The h squared is left. And the negative 8h. And then we could divide it by our h. We're almost there. We can reduce the h into all of the terms. And we can finish the problem. Our answer is now 2x. The h squared only cancels out with 1, so we just have an h left and a negative 8. So that's it. This is our finished answer for the difference quotient. It's 2x plus h minus 8.